From limitations to superpowers, a design approach to better focus on the possibilities of virtual reality to augment human capabilities. By Shadan, Sadeghian, and Marc Hassenzahl from University of Siegen. Over the last decades, virtual reality is used in a variety of contexts ranging from entertainment, education, to safety-critical systems and health. VR can offer rich interactivity, immersion, embodiment, and multisensory stimuli. The design of VR interaction techniques is often inspired and motivated by metaphors from either the real or magic realms. However, in applications that are not related to gaming and entertainment, most of the existing designs imitate real environments, tasks, and interaction techniques. Nevertheless, a VR design which aspires to be reality but does not successfully meet this goal will create a host of small mismatches. In turn, these mismatches impair user experience and productivity in the performed task. Although VR cannot yet fully imitate reality, a number of its attributes can actually enhance the physical, cognitive, and perceptual capabilities of the users and enable them to do things that are impossible in the real world. VR can augment the way we sense the world by, for example, giving us X-ray vision or filtered hearing. It can enhance our cognition by, for example, giving us a not-forgetting memory or unlimited knowledge access. And it can augment our physical capabilities by giving us the ability to fly or reshaping our own body. We call these the VR superpowers. In virtual environments, users interact with the environment and other users through avatars. While in immersive games, avatars are often augmented with superpowers such as telekinesis or flying, in non-game VR applications like remote presence, these augmentations remain an exception. The avatars are usually capable of doing a subset of tasks that are possible in reality. For example, their navigation is by walking or running in significantly bigger than reality virtual buildings. Or they can usually hear the sounds produced in their vicinity or audio zones. An explanation for this is that in non-game applications, VR interaction designers are already primed with real-world tasks and environments, and they simply transfer the real interaction to the virtual world. Another reason can be the acceptability of such interaction forms in the serious application context. To understand whether introducing VR superpowers influences the design of VR applications, we conducted a workshop. This workshop consisted of two parts in which participants were provided with prototyping material to create a prototype of a VR application for reducing stress and enhancing relaxation. At the beginning of the workshop, we gave participants a scenario for this application. In the first part, we asked participants to use the prototyping materials to create ideas of what the user experiences with the no-stress VR application. In the second part, we provided them with a list of 11 superpowers and asked them to try to incorporate them into their designs. The list consisted of the following superpowers: flying, intellect or information or access to unlimited information, super hearing, super sight, teleporting, shape-shifting or elasticity or size manipulation, X-ray vision, super strength, gadgets or having multiple tools as a body extension, invisibility, phasing or ghost or ability to move through objects and beings. At the end of each part, concepts and prototypes were presented through enactments and discussed. We used thematic analysis to structure the gathered data. For the detailed description of presented concepts, please refer to the paper. We found three categories in our thematic analysis: environment, including virtual environment elements, real or imaginary, and familiar or unfamiliar. Interaction, including type, consisting of observation, navigation, or manipulation, and modality, auditory, visual, tactile, or olfactory. And augmentation, sensing, cognition, action. The presentations from the first part of the workshop mostly included descriptions from the environment category, such as sea, waves, or a globe building. And these environments were mostly real except for one with flying task bubbles. The interaction offered was mainly related to observing or navigating in the environment. Only 2 examples of manipulation were mentioned. And except for the concept of bubbles reacting to breath, no augmentation was mentioned. Presentations from the second part, on the other hand, were focused mainly on interaction and augmentation. Only one participant described the environment elements in detail, which was the output of the interaction in the concept of creating a mini planet. All presented concepts involve multimodal interaction and range from observation or perception to navigation in and manipulation of the virtual environment. As expected, all participants created concepts in which they augmented perception, such as X-ray vision, filtering sounds, or perceiving the world through the senses of a turtle. One augmented cognition by enabling Sarah to sort her tasks rapidly. And 3 participants applied action augmentation by augmenting force for reforming the world, flying, and organizing tasks by gestures. Overall, introducing participants to superpowers led to concepts with more focus on interaction in the virtual environment. These results indicate that although introducing superpowers to designers lead to novel interaction concepts, there is a need for an experiential approach for integrating them in different application contexts. Therefore, we created Superpower Lab for Unity 3D. It allows VR application designers to augment virtual avatars with a range of preset superpowers. For example, for perception, focus tiering, filter tiering, zoomed vision, and X-ray vision. For cognition, super memory and super knowledge. And for action, flying, amplified force, and telekinesis. To gain feedback from potential users about their experience with Superpower Lab, we conducted an expert review with 12 VR designers and developers. Similar to the workshop, the first part was dedicated to introduction of no stress and creation of ideas of the virtual environment and interaction within no stress. The second part, we gave an introduction to the Superpower Lab and the rationale behind it, and after familiarization, we asked the participants to create an abstract version of no stress by using Superpower Lab. After presenting the results, a semi-structured interview was conducted. Our participants found Superpower Lab as straightforward, easy to use, simple to understand and implement, and helpful for quick prototyping of concepts. However, they said that it can be improved by adding documentation about the functionalities or having the possibility to create and customize superpowers by mixing the existing ones. They mentioned, it's interesting to think about it just as an element of interaction, not as a game element. Because usually you think like that. The first thing you think, okay, those things are happening in games, but it can also be just a part of a regular business application. I can imagine that, to just use those crazy things, let's say. Given our results, we conclude that the notion of superpowers combined with the possibility to easily experience them changed and widened users' perspective away from limitations and reality towards possibilities and the unique experience of being in VR. Moreover, having the tool like Superpower Lab invites experimentation with the unreal forms of interaction and has the potential to facilitate co-ideation with users and customers. Finally, we think that VR should not be thought of as a replacement for reality, but as an environment where humans can overcome many physical restrictions. While not each of these possibilities makes sense in every context, the mindset of augmentation and superpowers focuses designers on what VR is best at.